Hi everyone, let's discuss another Leetcode problem, and today's problem is 2781, length of the longest valid substring. So the problem description says, as you see, this is a hard problem, so we have to put a little bit thinking in it, obviously. So the problem description says that we are given a string, and also an array of strings forbidden. So one string, input string, a word, and also a list of words which are forbidden. A string is called valid. That means this string is valid if none of the substrings are present in forbidden. We have to return the length of the longest valid substring of the given string. So for example, and as we know, the substring is the contiguous sequence of characters. So for example, you see here the given string is CBAAAABC. That is a given string, and the forbidden strings are AAA and CB. Okay, and then we have to find the longest substring in it that doesn't have any of these forbidden words. Okay, so let's say if a substring, if we take as this substring, CBA, is it a valid substring? No, because it contains this, right? It contains CB. So this is not a valid substring. Or if we take, say, BAAA, is this a valid substring? No, right? Because this one contains AAA. Okay, so we have to find the longest substring that doesn't contain this or this. So how can I do that? So before doing that, obviously for any problem, what we have to do is we have to carefully look at the constraints. So you see the word length can be maximum of 10,000 characters. A word consists of only lowercase English characters. And then the length, how many forbidden words we can have, that is also 10,000 maximum. But this one, this fourth one, this is the most important one that is going to help us. So this one says the length of every forbidden word is at most 10. So it might be 1. So the length, that means there might be at most 10 characters in a forbidden word. This is going to be the key for our solution technique. Let's create an example ourselves. So let's say this is our string. This is the characters. Say this is the characters of our string. Okay, so these are the characters. And then say I want to check a substring at index I. At index I want to check the substring if the substring is valid or not. Now here is the thing. Since the forbidden word can be at most 10 characters long, can I say that I can just keep on, if I start checking from here, right, from here, I can just check 4, 5, 6, 7, 8, 9, and 10. That means I plus 9. That means if I start checking a substring, if that substring is valid or not, at most I can just go 10 characters and then stop, because if there was a forbidden word, that forbidden word is going to be detected before this, right? So the forbidden word can be at most 10 characters long. So any forbidden word in the list will be detected, if any, within this substring will be detected within this length, right? Okay, so this is substring, and this is the window you're checking, right? This is the window you're checking. Okay, so that is the highest we have to go. Okay, now let's see. let's say we start we said like we start checking from index I, right? Okay, so index I, say, okay, let's put all the forbidden words in a list. Sorry, let's put all the forbidden words in a list. So this is the list of the forbidden words, or in a set. So this is one, this is one, this is one. So, okay, so say there are 3 forbidden words, and in a this is the input string, right? So, and I'm checking a specific substring starting from index I. Okay, so what we can do is we can just keep on checking and see, read one character and see if that one character makes a forbidden word or not. No, right? The second character, no. The third character, these 3 characters form a string, but that's not a forbidden word. So we keep on doing this. And then after doing this, let's say one forbidden word was orange. And then we had this, erase this. Okay. So what's going to happen now? How actually we started checking from index I, that's fine. Now from index I, we started checking. First we checked if O is a forbidden word. No, right? So in that case, we are fine here. Is OR a forbidden word? No. Is ORA a forbidden word? No. Is ORAN a forbidden word? No. And finally, then we say like if ORANG, is this a forbidden word? No, right? So till this, the window is valid, right? Can we say this? We can say this is a valid window, right? Still, this is a valid substring. Oh, okay, so I made a mistake here. So we can say this is still a valid substring, OARNG. This was a valid substring. But as soon as we read next character E, this one now becomes an invalid substring, right? Invalid substring. Now tell me, if I expand this substring beyond, so if say I want to expand this substring to this direction, right? So if I want to add more to it, add something like this, is this going to be valid? No, right? Because part of it is invalid, and our condition says that we cannot have any invalid or like forbidden word, right? Okay, what about if I expand this whole thing here? Like if I say, if someone asks you, hey, is this substring a valid one? Still it's no, right? Because it has an forbidden word in it. So can we say that as soon as we find a forbidden word, can we just say that, okay, our validity window ends here, right? Our validity window ends here. That means next time when I am checking the validity of a string starting from I minus 1, this was I, right? When I'm checking a validity of a string from I minus 1, so I'm checking the validity of this string now, right? All I have to go is I have to go till this point, right? Let's say this point is, we call it the right wall or right boundary of a valid substring. This is the right validity. So let's put them together. That means starting from index I, how far we will go to check if the substring is valid or not. We first said like maximum we have to go I plus 9 to the I plus 9th index. That means 10 characters, right? Or we have to go to the right pointer, right? Or the right boundary. That means the minimum of, so from index I, when I am checking the validity of a substring, I will go either to the index I minus I plus 9, that means the 10 character, or the right substring, right? Okay, so that means three things. I will have a boundary, right boundary, and then I will have a starting point. Starting point might be like anywhere, like, right? So the starting point, we call it the left boundary. So let's say start or left boundary. And then I will have another pointer that's moving. So another moving pointer, let's say this is K, pointer K or something like this. Now let's go through one example and I think it will be more clear to you. Okay, so let's look at this example. You see that the word here is CB A B C. Okay, and the forbidden word, let's put it in a set. So the forbidden words are A and CB. Okay, so initially my right boundary is going to be here. I'll set it here. My starting point or the left boundary is going to be, so let's call this one left boundary also starts here. And as you see here, the left has nothing to move, right? So left is here and it has nowhere to move. So done. That means this is a valid substring, right? Because it's not in forbidden. So this is a valid substring. And what is the length of the valid substring? So the answer is, so far is, let's update the answer. Initially it was 0. And now we have a valid substring of length 1. So we update it with 1. Okay. Okay, next. The left moves here. And we can go up to 10 places, right? But there is just one place to move. So you see BC, is this a valid? Yes, this is a valid one, right? So it's still this is valid, so right remains in the same place. So the answer is now updated to 2. Okay, so left moves to the next place. So left moves to the next pointer, and now the substring that we have, A is valid, right? AB is valid, right? Okay, and then ABC, this is also valid, right? So the answer is now even bigger. So the length of the longest substring with validity is 3. Next, left moves to this one. Okay, so A is valid. We move the pointer to here. So AA is valid. AAB is also valid because there is no forbidden thing here, and AABC is also valid. That means AABC has a length of 4. This is 4. Okay, left moves here now. Now you see A is valid, totally fine, but the length is 1, so answer doesn't have to update. AE is valid, that is fine. AAA is valid. It's not actually. You see, AAA is here. So this is not valid. So what do I do? Okay. So since this is not valid, we don't need to check any further. Do I need to check AAAB? No, there is no reason to check that because already you see there is an invalid thing here. So we stop here. And what we do is, we know that we cannot, my substring next, whatever substring I try to make, it cannot include this. So as part of the discussion in the previous slide, we have to change the right pointer to here, right? Because the invalidity, like this was valid, these two was also valid, but this was invalid, right? So the right pointer now stops here. That means the right pointer is now set here. Okay, right pointer is set here. That's the right boundary now. So we change the left now to this, right? We change the left to this. Now let's see again. Is A valid? Yes. A valid? Yes. A, is it valid? No. Right? Okay, so what I have to do is I have to change the right pointer to this now because it became invalid here, right? Okay, I have to change the right pointer here. And meanwhile, you see that we are not actually getting any valid substring greater than, which is exceeding 4. That means answer is still stuck at 4. Okay, so the left now moves to here. Left moves to here. Now, is B valid? Is this substring valid? Yes. A valid? Yes. BAA, is it valid? Yes. BAA is valid substring. But the thing is, we have to stop here. Do I have to go like 10 places? No, because we know the right boundary. We go the minimum of right boundary and the 10 places, right? Okay. So we stop here, and the valid substring here has a length of 3, so answer has nothing to update. So answer is still remains 4. Okay. Next, left is set here. Okay. Now let's see. C, is it valid? Yes. CB, no, it's not valid. Okay. So the right pointer is changed to this. Oh no, actually CB, this is the invalid where invalidity happened. So right pointer is set here, but there by then already the left cannot move anymore. So we are done, right? There is no place for left to move to the left. Okay, so we are done. And you see in the process, we got the longest substring of size 4. So here is the code that I already have done. We take a hash set to store all the forbidden words. So we read a forbidden word and put it into the hash set, which I call invalid. Okay, so all the forbidden words are now in this set. And then we take this right pointer, where I set the right pointer to the end of the string, in end of the given word or string, right? Input word. And the answer is, as you see, initialize with 0. And then I start reading from the assigning the left pointer. As I shown from the example, the left pointer is initially going to be set to the end of the string, the last character, and the left pointer will keep on moving to the left, and it will stop when it will reach the beginning of the input string. And every time I will start from the left pointer and I will go either 10 places, right? Because of the constraint that says that the forbidden word cannot be more than 10 characters, or the right pointer, as I have shown, right? And we will just keep on moving, expanding our substring and see if it's valid. So if you see that the substring that we have so far from the left to this k+1, that is, we are actually moving one step at a time. If we see that current substring is actually an invalid word, that means if it's an invalid word, the current substring, if that is an invalid word, immediately what we do is I just go one step back, assign the new right boundary and break, right? Otherwise, if I never hit this, that means I have done the whole thing. I have found a whole not never, like if I haven't reached this, I have never broken out. That means I got a valid substring, and the length of that valid substring is this, right? Right minus left plus 1. So I see if answer needs to be updated. That means if this new valid substring is even longer than the previous valid substring, and I keep on updating. So I keep on doing this until I come to the left. That means the beginning of the thing. Okay. And finally, I return the longest, uh, the the length of the longest valid substring. Okay, so I hope you understood the explanation, and if you haven't, please go through it just one more time and it will make sense to you. Okay, so what is the time complexity of this algorithm? As you can see, we run this for loop, right? And the for loop actually starts from each character of the input word, and from each character it goes like length uh, like uh, 10, right? Okay, yeah. So yeah, from each character it goes like maximum of 10 places. So that means this is actually order of n into 10 for these algorithm. To better say it, we can say like for these algorithm it's order of 10n, n into 10, because the highest length of the any forbidden word is 10 here. But we can say the highest length, if the highest length is L uh, for any algorithm, so that would be order of n into L. That is the time complexity of this algorithm. And the space complexity is going to be, you see, we have used a hash set. Say we have m forbidden words and each of them has a length of L. So the space complexity is going to be order of m into L. Okay, so that's it. Thank you very much for watching.